Hi folks, today I have a lesson for you about determining the rate constant when the initial concentrations and the rate is given. So here is a question. The reaction between ethyl bromide C2H5Br and hydroxide ion is as follows. C2H5Br plus OH minus forms C2H5OH plus Br minus. The ratio between all of the substances is 1:1. In the question, it also states that it is first order with respect to each reactant. In other words, each reactant when changed will have an 1:1 effect on the rate of the reaction. In other words, when the reactant is doubled or the concentration of the reactant is doubled, the rate will also double. So when ethyl bromide is of the concentration of 0.0477 molar, and the hydroxide ion is of the concentration 0.100 molar in the beginning, the rate of disappearance of ethyl bromide is 1.7 times 10 power negative 7 moles per liter second, which is same as saying molar per second. We have two objectives in this question. We need to find the rate constant, the magnitude, the size, and the units for the rate constant. Now, you can do this question as a whole together, or we can do it in parts. In this case, I'm going to show you how to solve this question in parts. In the first part, part A, we are going to find the rate constant value. So I'm not going to put any units. And the second part, I'm only going to put units and no values, because in the second part, part B, I'm only looking for the units for the rate constant. Okay, so let's begin. So, what they have already told us that the rate is equal to K concentration of C2H5Br, which is the reactant, is to the first order. And the second reactant, they also said, is of the first order in the question. It says right here, first order with respect to each reactant, right? So it's to the power 1 or to the order of 1 and to the order of 1. So we have our initial rate law. Now, we can plug in the values or we can rearrange the equation first. So let's rearrange because we're going to be looking for the value of K. So K is equal to rate over concentration of C2H5Br and the concentration of OH minus, both to the power of 1. Plugging in the values, we get 1.7 times 10 power negative 7. And as I said, I'm going to just use magnitudes here, so I don't have to put the units. And if I was doing it together, I would keep the units here. Okay, and divided by the concentration of C2H5Br initially was 0.0477 to the power of 1 and 0.100 to the power of 1. I have all the values in place. Now I just have to use the calculator and calculate. Once I plug in all of these values into the calculator, I get 0.0000355,872. Okay, so that's the value, and I can write it down in proper scientific notation. 3.56 times 10 power negative 5. Okay, so that's part 1. We have found the value of the K. We haven't found the units. For the units, we will follow the same process. We know that K is equal to rate. So K is equal to the rate. The units for the rate were moles per liter per second over the units for the concentrations was molar to the power of 1, and this also was molar to the power of 1. Okay, I'm just doing it because if it was 2, you have to account for the 2 and the 3 and the 4. If it was to the power of 2, then it would be big M squared, or if it was 3, then it would be M cubed. Okay, Now once we have that, I can simplify this and say, okay, this is the same as saying moles per second, and this is moles times moles, or molar times molar, and that molar cancels out, molar concentration or moles per liter cancels out. Now we have leftover is s to the power of -1 and m, which we can also say as to the power of -1. So the units are per moles per liter per second. So the final K value, if you had to write a final K value, K was equal to 3.56 times 10 power -5 per molar per second. I hope you'll find this lesson useful, and if you did find it useful, please hit like, and if you have future requests for questions, please feel free to let me know so I can bring videos to you that relate to your questions.